This is video tutorial number 6, limiting reagent, and the problem is written at the top. Acrylonitrite C3H3N is used in many synthetic fabrics. It is produced by the following reaction, and the reaction is given, and it's already a balanced equation. So this is the reaction we'll be working with. The question says, if 15 grams of C3H6, 10 grams of oxygen, and excess ammonia are reacted, what is the theoretical yield of acrylonitrile C3H3N? How much excess reagent will be left over? And if the actual yield is 9 grams, they want you to find the percent yield. Our first step, any reactant that is said to be supplied in excess, we will ignore. That means it does not limit the reaction in any way. It will not run out before the products are made. Using the grams of the reactants given, we're going to find the possible moles of product for each gram amount put in. We're going to take the reactant that produces the lowest number of moles of product and say that that is the limiting reagent or limiting reactant, and we're going to convert moles of product to grams of product to get the theoretical yield. We're going to start with the limiting reactant again to find moles of excess used. We'll subtract from the amount put in to find the amount left over. And finally, we'll use the actual yield and the theoretical yield to find the percent yield. We'll do actual over theoretical times 100 to get our percent yield. So I have a couple of things on the next page here for our video tutorial here. Don't forget, first thing we want to do is find our gram formula masses. I don't think anyone needs help finding those. Those are there done already for you. I'm just going to pop that over on the side there. I rewrote the balanced equation so that I can refer to that. And I'm going to start with my gram amounts of the two amounts given, the two reactants given, to see what the moles of product possible are for those amounts, to see which one is the limiting reagent. So I start with the 15 grams of C3H6. I convert it to moles. And we said that was 42.08 grams of C3H6 is 1 mole. And in my balanced equation, the coefficient of C3H6 is a 2. The coefficient of C3H3N is a 2. So we make 2 moles of C3H3N for every 2 moles of C3H6 put in. And that is going to have a possible yield of 0.356464 moles of C3H3N when we cancel out all of our units that were alike. Our final answer comes out in moles of C3H3N, and we get a possibility of 0.356464 moles. Now starting with the oxygen, our 10 grams of oxygen also gets converted into moles by multiplying by the molar mass underneath to get rid of grams and the 1 mole over the top. Now in my balanced equation here, the coefficient of my oxygen is a 3 and the coefficient of my C3H3N is a 2. So I'm going to multiply by 2 moles of product for every 3 moles of O2 in. That cancels out my moles of O2, and the possibility here is 0.208333 moles of C3H3N. Now, because this number is a smaller number than this number, that means that my oxygen is limiting. That means that my C3H6 is my excess reagent. Because this is my amount of moles that can be produced from my limiting reagent, I can take that number and multiply by the GFM for C3H3N, which we said was 53.06 grams for every 1 mole And if I multiply that number out, my theoretical yield is 11.1 grams. Picking up video tutorial number 6, we just found the theoretical yield. And the next thing I need to do is find out my amount of excess reagent. We said that C3H6 was the excess reagent. We're actually going to start with our grams of O2 and convert that to moles so that we can figure out how many moles of C3H6 were actually used. Once we find out the amount of moles of C3H6 that were used, we can subtract that from the amount that we put in to find out how much is left over. So we're going to use the coefficients from the balanced equation, and now that we're starting again, we're starting with our limiting reagent, and we're saying, okay, we're in moles of oxygen now, and for every 3 moles of O2, because that's the coefficient of oxygen, we use 2 moles of C3H6. That's the coefficient of C3H6. And now moles of oxygen are canceled, and our final answer will be in moles of C3H6. And we use 208.20833. I just didn't round that out of the calculator for significant figure purposes. So now, if I convert this to grams by multiplying by the GFM, which we have written over here as 42.08, I find out that 8.77 grams of C3H6 was used. We know that we started with 15 grams, so we subtract. That means that there's 6.23 grams of C3H6 left in excess after the reaction. And our last step is to do the percent yield. We found our theoretical yield up here as 11.1 grams. And our percent yield, it said in the problem that 9 grams were produced. We put that over the 11.1 and multiply by 100. And when we do it on the calculator, we get that it was 81.1% yield. So that was the video tutorial number 6 on limiting reagent. Hopefully that was helpful.